You've been sleeping wrong your entire life. Not completely wrong, but wrong enough that it's quietly costing you memory, mental sharpness, and possibly actual brain volume. I know that sounds dramatic, but here's the thing. Sleep is the one activity you've done every single night since birth, and there's a good chance nobody ever taught you how it actually works. They just told you a number. 8 hours. Get your 8 hours and you'll be fine. Except the science says that number is wrong. While you're unconscious every night, your brain is running the most sophisticated optimization program in nature. It's consolidating memories, rebuilding neural pathways, literally growing and shrinking different regions based on choices you didn't even know you were making. And understanding what's actually happening during those hours changes everything about how you approach rest. Let me show you what I mean. The 8-hour rule. You've heard it everywhere, from your parents, your doctors, every health article you've ever clicked on. 8 hours is the gold standard, right? The magic number that separates the well-rested from the walking zombies. But when researchers actually tested this, and I'm talking about one of the largest sleep studies ever conducted, tracking over 500,000 people through something called the UK Biobank, they found something that contradicts almost everything we've been told. The cognitive sweet spot isn't 8 hours, it's 7. 7 hours of sleep produced the highest scores across every cognitive measure they tested. Memory performance, reasoning ability, processing speed, executive function, all of them peaked at 7 hours, not 8. Now, I'm not saying sleep less and feel superior about it. There's a range here. The research shows stable cognitive performance anywhere from about 5.5 to 7.5 hours. But the peak, the absolute optimal point for brain performance, it sits right at 7. So why have we been told 8 for so long? Partly tradition, partly because 8 is a nice round number that divides the day into neat thirds, but the data tells a different story. And here's where it gets really interesting. The relationship between sleep and cognitive function isn't a straight line where more is always better. It's something far more surprising. We all know that too little sleep is bad. Pull an all-nighter and you feel it immediately. Chronic sleep deprivation and you're running on fumes. No surprise there. But here's what most people don't realize, and it's genuinely unsettling. Too much sleep is just as damaging as too little. It's called a U-shaped curve. On one side, you have sleep deprivation. Below about 4.5 hours, cognitive function craters, attention suffers, memory fails, your brain essentially starts misfiring. On the other side, above 8 to 9 hours regularly, something similar happens. Cognition declines. Not as dramatically at first, but it declines. And brain scans prove it. When researchers measured gray matter volume across 46 different brain regions, they found the same pattern. Too little sleep, brain regions shrink. Too much sleep, those same brain regions shrink.
Your brain physically changes based on how much you sleep. Not metaphorically, literally. The volume of actual brain tissue responds to your sleep duration, and the optimal point for maximizing that volume sits right in that 6 to 8 hour window. Sleeping 9 hours isn't giving you bonus recovery. It's actually costing you the same cognitive ground as sleeping 5. So what's happening during those hours that makes the amount matter so much? Most people think of sleep as the brain's off switch. You close your eyes, consciousness fades, and your brain takes a break until morning. That's not even close to what's happening. During sleep, your brain isn't resting. It's working, and in some ways, it's working harder than when you're awake. Sleep comes in stages. You've probably heard of REM sleep, that's when you dream, but there's also non-REM sleep, which includes slow-wave sleep, often called deep sleep. These aren't just different levels of unconsciousness, they're different modes of brain operation, each one handling critical tasks. During REM sleep, your brain is often more metabolically active than during waking states. Neurons are firing, neurotransmitters flood through circuits. It's intense work happening behind closed eyelids. During slow-wave sleep, your brain shifts into a completely different gear. Electrical activity changes. Long, slow oscillations ripple through your cortex. This is when some of the most critical maintenance work happens. Sleep is less like shutting down a computer and more like running essential system updates. The machine looks inactive from the outside, but inside, crucial processes are running that can't happen while you're using it. Here's what that actually looks like. Every day, you take in enormous amounts of information. Conversations, things you read, experiences you have, skills you practice. Your hippocampus, this small curved structure deep in your brain, acts like the world's most overworked intern, frantically taking notes all day long. But the hippocampus can't hold everything forever. It's not designed to. It's meant to capture information quickly, then transfer the important stuff somewhere more permanent. And that transfer happens during sleep. While you're unconscious, your hippocampus starts replaying the day's experiences, not at normal speed, but roughly 10 to 20 times faster. It runs compressed highlight reels of what you experienced over and over throughout the night. This process, called neural replay, moves memories from temporary storage in the hippocampus to long-term storage in the cortex. During slow-wave sleep, this replay triggers a cascade of activity. Connections representing important memories strengthen, weak connections fade. By morning, what was fleeting becomes stable. But here's where it gets counterintuitive. One of the most important things your brain does during sleep is actually weaken connections between neurons. That sounds backwards, right? Doesn't learning mean strengthening connections? Yes, during the day. While you're awake and learning, synapses strengthen. Every new skill, every piece of information reinforces certain pathways. But if that continued indefinitely, the system would overload. It would be like highlighting every word in a textbook. When everything is emphasized, nothing stands out. So, during sleep, your brain performs something called synaptic downscaling. It turns down the volume on connections formed during the day. The strongest, most meaningful connections remain relatively strong. The weaker, less important ones fade away. The result is a better signal-to-noise ratio. The important information stands out more clearly. This is why things often click after sleeping on them. Your brain hasn't just preserved the information, it's refined it, distilled it down to what actually matters. Different types of memories get processed in different sleep stages too. During slow-wave sleep, your brain primarily consolidates declarative memories, facts, events, things you can consciously recall. During REM sleep, it shifts to procedural memories, skills, motor patterns, how-to knowledge. These stages cycle throughout the night, each building on the last. Cut sleep short, and you often cut REM first, which dominates the later hours. You might remember the facts from yesterday's meeting, but lose progress on the skill you were practicing. Both stages matter. Skip either one, and you lose half the benefit. When the system breaks down from sleep deprivation, memory disrupts at the molecular level. Long-term potentiation in the hippocampus, the process that locks memories in, stops working properly. Chemical signals misfire. You experience information, but it doesn't stick.
Adenosine, the chemical that signals fatigue, builds up faster than your brain can clear it. Neurons begin experiencing brief off periods while you're still awake. Microsleeps happening inside your brain without your awareness. You're awake, but parts of your brain are asleep. Here's something else most people don't realize. Some people wake up energized at 6 in the morning. Others struggle before noon. This isn't about discipline or willpower, it's biology. Your chronotype is largely genetic. Night owls aren't broken morning people. In fact, research shows evening types often outperform morning types in complex reasoning and creative problem solving. They're just wired differently. Aligning your sleep schedule with your natural rhythm, not fighting it, leads to sharper thinking and better performance. Forcing yourself to be a morning person when you're genetically programmed to be a night owl doesn't make you more disciplined, it just makes you chronically tired. And here's the kicker. Sleep quality predicts cognitive performance better than sleep duration. 6 hours of deep, uninterrupted sleep can outperform 8 hours of fragmented rest. People often overestimate how much they actually sleep. EEG recordings show we're frequently wrong by about an hour. Light sleep and brief awakenings don't count the way we think they do. You might be in bed for 8 hours, but only truly sleeping for 6.5. Quality is the real optimization lever here, not just time in bed. Your brain physically reshapes itself every night. Imaging studies show sleep duration predicts gray matter volume in 46 brain regions, including areas responsible for memory, decision-making, emotion, and movement. The relationship follows that same U-shaped curve, optimal around 7 to 8 hours, with decline on either side. The good news? Some of this damage appears reversible. Improve your sleep habits consistently, and brain volume can partially recover. Your brain has more plasticity than we used to think. So what does optimal sleep actually look like? It's not about chasing one magic number. It's about 4 variables working together: duration, quality, timing, and stage protection. 7 hours is a strong target for most people. Deep, uninterrupted sleep matters more than total time in bed. Align your schedule with your chronotype instead of fighting it. Protect both slow wave and REM sleep by giving yourself enough total time. These factors multiply, they don't just add. Get duration right, but quality wrong, and you lose most of the benefit. Get quality right, but timing wrong, and you're still fighting your biology. Your brain is doing extraordinary work while you sleep. It's not downtime, it's not wasted hours. It's the most sophisticated maintenance and optimization program in nature, running automatically every single night. Most people treat sleep like an inconvenience, something that gets in the way of productivity. But sleep is productivity. It's where your brain consolidates what you learned, refines what matters, and literally reshapes itself to be sharper tomorrow. The number you've been chasing might be wrong. The 8-hour rule isn't gospel. But understanding what's actually happening during those hours, that changes everything. Your brain is rebuilding itself every single night. The only question is whether you're giving it what it needs to do that job right.